The Deepwater line of business is one of Shell's most important investment priorities. With decades of experience in deepwater, we continue to drive an innovation agenda focused on safe and robust operation so that we can responsibly unlock energy resources for future generations. Globally, we operate a large number of subsea facilities, and the surveillance and integrity of that infrastructure is extremely critical, and it must be a part of our innovation agenda. Subsea inspection is a key aspect to verifying the integrity of those facilities and that infrastructure that rests on the seabed. Common approaches for subsea inspections utilize either divers or remotely operated vehicles, ROVs. These vehicles are controlled by human operators from a surface vessel. As our infrastructure expands globally, we will be using more ROVs in our operations and more divers, resulting in higher inspection costs and higher HSE risk. We believe there is a simpler approach that will allow us to dramatically reduce costs and lessen the HSE risk. With artificial intelligence and advances in autonomous underwater vehicles, Shell has developed new and innovative solutions to deliver subsea inspections.
Through collaboration, we can maximize leveraging the expertise and capabilities of our vendors, and together we can deploy the technology faster and quicker so we can make business impact to our global assets.
The autonomous inspection vehicle, developed by Subsea 7, is a highly maneuverable underwater vehicle that is able to perform an autonomous subsea inspection, alleviating the necessity of support vessels. Subsea 7's autonomous inspection vehicle is marketed as having several advantages over the torpedo-shaped autonomous vehicles, such as enhanced ability to stop, hover and move close to the structures, improved real-time decision-making using artificial intelligence, and there is no need for surface vessels to aid navigation. Over the last 2 years, Shell has been working with Subsea 7 to extend its capabilities and complete a commercial qualification program. As part of it, we recently conducted a sea trial at one of Shell's offshore assets. The purpose was to test various technical aspects of the autonomous inspection vehicle in real-life situation. In a first for the industry, we'll be using an autonomous vehicle to accomplish a riser inspection on a live asset, as well as an inspection of the subsea structures. The significance of this trial is to enable seabed-to-surface inspections of risers, mooring lines, and tendons.
Specifically on the inspection, it focused on visual inspection and some close visual inspection. And I was particularly keen to see, can we really get up close and personal to some of this live asset? The AIV technology that we've jointly developed in collaboration with Subsea 7 has a couple of distinct advantages over the existing methods of operation. It is deployed on the seabed. It can launch from the seabed, gather the information, run its missions, come back. We can download that data, we can then process that information, and we do that with less exposure to the individuals on those vessels in that offshore world. That is of fundamental importance for us because it reduces the HSE exposure.
With this innovation approach, we have greatly expanded the available set of inspection capabilities, allowing for a more comprehensive set of results at lower cost and lower risk with a higher rate of inspections. The autonomous inspection vehicle will allow us to boost asset integrity for our underwater facilities.